Pythagoras theorem. Definition. In a right-angled triangle, the square of the length of the hypotenuse, the side opposite to the right angle. Here, the side opposite to the right angle is AC, is equal to sum of squares of the lengths of other two sides. Here, right angle triangle is given. The side opposite to the right angle is AC, BC is vertical side, AB is base. By definition, AB square, that is base square, plus BC square, that is vertical side square, is equal to hypotenuse square, that is slant side AC square. The angle opposite to right angle is small b, that is length of side AC, base length AB, that is small c, vertical side length BC, that is small a. By definition, c square plus a square is equal to b square. Here we see some Pythagorean identities or trigonometric identities. Let us consider angle A. Sin square A plus cos square A is equal to 1. 1 plus tan square A is equal to secant square A. 1 plus cot square A is equal to cosecant square A. By definition, AB square plus BC square is equal to AC square. Divide each term by AC square. That is AB square by AC square plus BC square by AC square is equal to AC square by AC square. Here AB is base, that is base square, by AC is hypotenuse, that is h square, plus BC is vertical side, that is v square. AC is hypotenuse, that is h square, is equal to AC square gets cancelled 1. B by h whole square plus V by h whole square is equal to 1. So base by hypotenuse, that is cos A whole square, plus vertical side by hypotenuse, that is sin A whole square, is equal to 1. Rearranging terms, sin A whole square, that is sin square A, plus cos A whole square, that is cos square A, is equal to 1. Equation 1. First identity, hence proved. By definition, AB square plus BC square is equal to AC square. Divide each term by AB square, that is AB square by AB square plus BC square by AB square is equal to AC square by AB square. AB square by AB square cancel, that is 1, plus here BC is equal to vertical side, that is V square, by AB is base, B square is equal to AC is hypotenuse, that is H whole square, by AB is base, B square. 1 plus V by B whole square is equal to H by B whole square. 1 plus vertical side by base. Vertical side by base, that is tan A whole square is equal to hypotenuse AC by base AB is secant A whole square. 1 plus tan A whole square, that is tan square A is equal to secant A whole square, that is secant square A. Equation 2. Second identity, hence proved. By definition, AB square plus BC square is equal to AC square. Divide each term by BC square. AB square by BC square plus BC square by BC square is equal to AC square by BC square. Here AB is base square by BC is vertical side, that is V square, plus BC square by BC square is 1 is equal to AC is hypotenuse, that is H square, by BC is vertical side V square, B by V whole square plus 1 is equal to H by V whole square. Here base by vertical side is equal to cot A whole square plus 1 is equal to hypotenuse by vertical side, that is cosecant A whole square. Rearranging terms, 1 plus cot A whole square, that is cot square A is equal to cosecant A whole square, that is cosecant square A. Equation third identity, hence proved.